A very good morning to Dr. Nik Shahida Afifi binti Muhammad Tajuddin, our lecturer for BJ 30303 Computer Architecture and Organization. So we are from Group 1, which consists of 3 members, Muhammad Amirul, Awanku Shafiq and me Hemal Roshni. So today we're going to present our group assignment. So these are the content of our group report. So first of all, I would like to start our group assignment by presenting the introduction. So in order to achieve the SDG, which is known as Sustainable Development Goal, and ensure the access to affordable, reliable and sustainable and also modern energy for all, there is a need to speed up the energy efficiency. So the energy efficiency can be attained by developing an efficient computer design. Therefore, in this project, we explore a modernized computer organization by using the LMC, which is known as Little Man Computer Simulator. So the instruction consisting a program to be executed by a computer are also loaded in a sequential location in its main memory. So to execute this program, the CPU fetch one instruction at a time and also perform the function. Therefore, the instructions are fetched from sequential memory location until the execution of branch or jump instruction. Therefore, the CPU keep track of the address of the memory location where the next instruction is located through the use of dedicated CPU register, which is known as PC. PC are the program counter. So after fetching an instruction, the content of the PC are updated to the point at the next instruction in sequence. So for simplicity, let's first assume that each instruction occupies one memory word. Therefore, execution of one instruction requires the following 3 steps, which is the fetch the content of the memory location pointed by the CPU, and the content of this location are interpreted as an instruction to be executed. So hence they are stored in the instruction register, which is known as IR. Then increment the content of the PC by 1. And also carry out the action specified by the instruction stored in the IR. So the first 2 steps are usually referred to as fetch phase, and the step 3 is known as execution phase. So the fetch cycle basically involves read the instruction from the memory into the CPU, and also along with the update the content of the program counter. So in the execution phase, it interrupts the opcode and perform the indicated operation. So these are the basic instruction cycle that I have explained just now. So next, for the derived equation, so these are the equation that we use for our group assignment, which is Z equal to A plus B and also D divided by E minus C and also minus with the X square. Therefore, the sum of this will time with the sum of the A plus B. So our derived equation consists of addition, subtraction, multiplication, division and also power of 2. So the variable is declared as A equal to 8, B equal to 7, C equal to 4, D equal to 10 and E equal to 6, also X equal to 2. So
okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Adam. I will talk about the coding and the simulation. Okay, first the equation we choose is Z equal to A plus B multiplied with D divided by E minus C and minus X power by 2. Then the variable we put here is A, B, C, D, X, and the number we put is A equal to 8, B equal to 7, C equal to 4, D equal to 10, E equal to 6, and S equal to D. So when we insert this input to the equation, we will get the manual calculation, we get the 15, and then we will see after this if our simulation will get the 50 or not. Alright, so for this we divide by 6 steps. First we do addition, is A plus B, and then subtraction is minus E minus C, division D we divide by E minus C, power of root we will do the power of root as power of by 2, and subtraction D divide by E minus C, we subtraction we minus with X power by 2, and then multiplication is the answer of A plus B, we multiply with the answer D divide by E minus C minus X square. Then we will get the answer 15. Now we will look the coding. So first we need to input the data for our A and B variable into the coding. So our A variable is 8 and 7. We need to store it at the 99 address, and for the variable A, and the variable B we put at the 98 address. Then we use add as the command to add the value of the 2 variable A add minus with 7. Then we go to the subtraction. Okay, we go to the subtraction. We do the subtraction part of the variable E minus C. Same as the addition part, we need to input the data variable E and C. We said E is 6 and C is 4. Okay, into the coding by declare is a store 96 for the variable E and 95 for the variable C. Then we use the subtraction as the command to do a subtraction operation of the 2 variables. Okay, then this is a subtraction command. Alright, we go to the division. For division, we load back the value of the subtraction that we do before this. Then we need to input the value D, which can be declared as the store D. Okay. Now we can divide the variable of D and the variable of value subtraction operation before. The answer will be stored at the 92 address 92. Alright. Okay, then we go to the power of root, which is the x power x square. For the x square, the value x will be load, which is 2, and multiply with the value of x because this is the power by 2. So we just multiply with x again to get the answer of for the square root. Then the answer will be stored at the p. Then for the next we do the subtraction. The address 92 will be load back at the will be subtract value that we store at the p before. We store the power of p, and then we subtract with the value at the address 92. The answer we store at the address 91. And lastly, we do the a plus b multiply with the answer d divided by e minus c minus x power of 2. Okay. Okay. Next we go to the coding part. The coding we do at using the determined computer. So first we need to input the coding we do at here. This is our script for the coding, and then we press submit, and we press run. Okay, the run we run the first coding. We put this is we take the 0 for the first instruction. Then we put the first input. The first input is A. We put the input of A is 8. So we put here 8. Okay, the 8 will store at the 99 address. Okay, we will see. We take the 399 here. Then it will store at the 99 address. Okay. Okay, next it's ready for the next input. We want to insert the next input, which is b equal to 7. Okay, we put the 7 and press enter. Then it will store do the store at the 98. Then it will do the operation add operation. Okay, we run the little fast. Right. Okay, it take back, and then it will do the take the value, and then it will add the arithmetic unit. Okay, and store at the address 97. So at the 97 we store 15 here, so that we will use after this. Alright, so after that we run the next input is is E. E is 6. Okay, 6 enter. Okay, we will do the last input. Then next we minus with C. C we choose 4. Okay, so after the minus it will get the 2. Then after that we put next coding is D. It is 10, and then it do the calculation. So it's quite fast here. Then we get 5, and then after that we put the variable of x, which x is 2. So it will do the power of root by x 2, and then do the minus, then do the multiplication. So the answer will put at here. So we get after the last output is 15. So same with the manual calculation. That's all from me. Thank you.
Assalamualaikum, my name is Awan Kushafiq. So today I want to present for discussion. So first step will be the y input for variable A and B will be saved in address 99 and 98. Then we will find the outcome will be saved at address 97. Then we will try to deduct the input of variable E and C. Then we place 96 and 95, and the result is at location 94. Then after we done the generate, then the address M is generated. Then variable H has been set to the one in the previous step. Then the result will be saved in the database at address 92. Then we will find the value of variable X be looped at both addresses X and Y in the input. Then we will loop through P and 92 and add the two values together. Then we get the value of 97. Then we subtract from the value at address 91. Okay, then after complete previous step, then we must first subtract the value from address 90 in order to save the value in address 99. Then after we get all the solution and at location Z, then we go to the equation. Then what we get is 15. So What we get is successfully deduct the assembly language code and solve this problem. Then for the conclusion, we have to needed to write code capable of carrying out all necessary operations. Then what we learn from this programming is we get the register RO through R99 has 3 bits. Then lastly, we will improve and control by employing various coding techniques based on the equation. So that's all for me. Thank you.